Okay, so this is number one. Or actually, it's not number one. It was the top left one on the page, but I think it was the back of the page. The first thing you do in these is you've got to get all of the variables on one side and the constant on the other side. So I'm going to add 182x and add 2y squared to this side, like so. And I'm going to subtract 319 from this side, from the right-hand side. All right, let me just, that means those cancel, whoops, cancel, cancel. What I've got here is I've got an x squared, a y, and a y squared. I'm going to write it like this, 13x squared plus 182x. I'm going to leave a space, and that's on purpose. And then plus 20, sorry, I want the y squared first. So plus 2y squared plus 24y. Okay, that's the entire left-hand side, equals, the only thing left on this side is negative 319. Okay, what you're going to do first of all is factor out any leading coefficient that isn't 1 from x squared and from y squared. So I don't know, but I'm going to say 182 divided by 13, enter. Oh wait, I entered that wrong. 182 divided by 13. There we go, that's 14. So I'm going to factor this out right here and get 13 times x squared plus 14x. Leave that space, okay, plus, I'm going to do the same thing right here to the y's because I want my leading coefficient to be 1. So it's going to be 2 times y squared plus 12y plus, I'm going to leave a space there, equals negative 319. Now the goal is, first of all, the 13 comes down, okay? Right here, you're going to get an x plus or minus something squared. And right here, you're going to bring that down, and you're going to end up with y plus or minus something squared equals negative 319. Now, here's how you figure that out. The first thing you do is you half that number. Half of 14 is 7, so that's going to be x plus 7. Now, then you take that 7. The reason you left that blank right there is you need to square that. 7 squared is 49. Okay? Now I want you to notice I just added that arbitrarily to the left-hand side, which means I have to add it over here as well. I want to point something out, though. I didn't just add 49. I actually added 13 times 49 because it's being acted on the left-hand side by that 13. So I'm going to add whatever 13 times 49 is, and I'll figure that out in a minute. Okay? So the next thing I'm going to do, so notice, by the way, my 13 times the quantity x plus 7 squared. I'm going to do the same thing here. Half the 12, so that's 6. Square the 6, that's 36. You added 36 within the parentheses on which the 2 is acting, so you actually added 2 times 36. Okay, so, and let me just erase that. Okay, so I'm going to do the math here. I've got negative 319 plus 13 times 49 plus 2 times 36. And when I add those up, I get 390. And I'm just going to double check. Negative 319 plus 13 times 49 plus 2 times 36. Okay, 390. 390 over here. So your goal is to try and, well, not try, you have to get over here on the right-hand side, that has to be a 1. Okay, and the way you do that, once you've got it written as quantity squared and quantity squared, is you divide by that whole quantity. So divide by 390 here, which means you divide by 390 on the y's, and then you divide by 390 on the x's. Okay, so now I'm just going to do the math. if I have 390, I want to see if 13 goes into it, so I can simplify that fraction. Right, clear. 390 divided by 13. I believe it's gonna, did it again. 390 divided by 13, and it's gonna be 30. So this part right here, if you divide 13 out of that, you get 1. Divide 13 out of that, you get 30. So the left hand, or the x part here, becomes x plus 7 quantity squared over 30. Plus, I'm going to do the same thing. 2 into 390 would be what? 150 plus 45, so 195. I'm just going to double check because I don't trust my math this late at night. Okay. So this is going to end up being the quantity y plus 6 squared over 195 is equal to, and 390 over 390 is 1. Now it's in standard form. So what you have to do is figure out how to graph that and how do you get your different points. So the first thing you do is on your axes, and I'm just going to scooch over here a little bit. On your axes, and we'll make them right here. Okay. You have to figure out what the square root of 30 is approximately. Clear. So the square root of 30, I don't know why it keeps double clicking, is about 5.5, 5.48, and the square root, clear. I'm gonna have to just X out of that. This is the square root of 30 is about equal to 5.48. Okay, and then on the other one, square root of 195. Did it again. Square root of 195 is about 13.96. Okay. 13.96. All right, so I know that the axis that goes right and left, I'm going to be jumping about 5.5 from the vertex, and I know that the axis that goes up and down, and by the way, I know that this is up and down because y, which is what it's under, is up and down. Okay, and I know that this is right and left because it's under the x, and x's go right and left. So the next thing I have to find is the vertex. The vertex here is going to be the opposite of what's inside the parentheses adding to x, so -7, and the opposite of what's in the parentheses adding to y. So I go first of all to -7, 1, 2, 3, 4, 5, 6, 7, -1, 2, 3, 4, 5, 6. This is my vertex. I put a little v beside it because I'll lose it sometimes if I don't. In the x direction, I'm going to go about 5.5. So 1, 2, 3, 4, 5.5 is right there, and then back. 1, 2, 3, 4, 5.5, right there. Notice I put little lines instead of dots, and the reason that I do that is because if you put a bunch of dots on there, sometimes I lose which one was my vertex. Now then in the y direction, I'm going to go up about 14. So up 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. It's right there. And do the same thing down. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Right there. So those dots actually help, or little lines, zoom out, help to define my ellipse. And my ellipse is going to be about like this. Some ugly numbers, by the way. All right, so that is my ellipse. Keep in mind that what you're going to do to find like the foci for an ellipse, you always do the opposite of what's in the middle of the standard. Like I always want to say a squared plus b squared equals c squared, but if it's an ellipse and there's a plus, you have to do a squared minus b squared equals c squared, because c gives you how far you jump to get to the foci. So here's the thing. Don't try to memorize which one is A and which one is B. A is the bigger one. Okay, so if A is the square root of 195, that would be the square root of 195 squared minus, keep in mind A is the bigger one because if you subtract, that's the only way you could get a positive number, and c squared is going to be a positive number. So the square root of 195 squared minus the square root of 30 squared is equal to c squared, c being the distance you would hop from the vertex to get to the focus. So that would be 195 minus 30 equals c squared, which would be 165 equals c squared. So c is equal to, technically, if you're just solving the equation and you didn't know that it actually represented a length, it would be plus or minus the square root of 165. But keep in mind, we are dealing with a length here, so you would really just say c is equal to the square root of 165. So if you look on your calculator, square root of 165, it's about 12.8. Now the foci will always be along the major axis. Okay, so I'm going to go up 2, 4, 6, 8, 10, 12.8 is like right about there. Okay, and then I'm going to go down 2, 4, 6, 8, 10, 12, and it's going to be right about there. So that's one focus, and that's the other focus. Remind yourself again, this point right here is -7, 6. So if you wanted to write this in shorthand rather than with decimals, the focus here is going to be up square root of 165 from the 6. So the focus here, you could say, is -7, because they're all at the x value -7, comma, 6 plus the square root of 165. And the only difference for the other focus is that you went down, so you will say 6 minus 165. So -7, 6 minus the square root of 165. And you might be asked the length of the major axis. The major axis is always the longer of the two. Well, that length from, remember these were the y jumps, and the length of those was roughly 13.996, so you could say that the length of the yellow segment right there is the square root of 195, and then this is the length of exactly the same segment but in the opposite directions. So the length of the major axis is just the sum of the two. So the major axis length, if you are asked that, is 2 times the square root of 165. The minor axis length would be 2 times the square root of 30. Lastly, if you are asked for the endpoints of the major and minor axis, you kind of, I get to it exactly the same way as I did with the foci. This, remember, was the square root of 30 in the x direction. So one of the endpoints of the minor axis would be -7, and you went in a positive direction, so plus the square root of 30, comma, 6. And this one would be -7 minus the square root of 30, comma, 6. Same exact process, but for the major ones, you're going to add this value, which remember was the square root of 190. Oh, I probably confused you. Hold on. That should not be 165. That should be 195. Messed that up. Sorry. Hold on. That should say the square root of 195. Okay. So this would be No, I'm wrong. I'm wrong. I'm sorry. That's the foci. Let me fix it back. Did I get it that time? Yeah. So this would be, sorry, the endpoint here would be, and let me zoom in and show that, would be -7, 6 minus the square root of 195. I got confused for a minute. And this would be -7, 6 plus the square root of 195. Okay, so all of the things that you might be asked, which could be what is C, what are the foci, there's the foci, what are the endpoints, oh, you're not going to be able to see that, the endpoints, I'll circle it, of the minor and then major axes are right here.